Welcome to the trading floor. Listen, exam day in Cambridge mathematics is absolutely not just a test of what you know. It is a high-stakes test of split-second decisions. Every single minute you spend in that exam hall is currency, and you need to invest your time exactly where the marks are highest. Today's strategy session is your ultimate no-nonsense masterclass in exam strategy. Whether you are sitting syllabus code 0580, 0606, 4024, 4037, or 4040, the rules of the game are exactly the same. We are zeroing in on the notorious, grade-defining topic of function notation. We're talking about complex, multi-layered functions, things like f of x equals 2e to the power of x and f maps x to log x. I want you to think about two typical students taking this exact exam. Let's call them Alex and Sam. Now, when confronted with a complex function question, Alex completely overloads the page with raw mathematical facts. Alex dumps every single equation they've ever memorized onto the paper without any clear analysis or structure. It's just a wall of numbers. Sam, on the other hand, does the opposite. Sam looks at the clock, completely panics, and just rushes. Sam completely misses the specific command word requirements of the question, drops massive easy marks despite actually knowing the underlying math perfectly well. Right now, if we look at their papers side by side, it's just a sea of red pen marks. Today, we are going to look closely at their flawed approaches, analyze exactly why those red marks happen, and transform those answers into the perfect high-yielding green checkmark responses that Cambridge examiners are desperately looking for.
Okay, let's take a quick look at our agenda. Here is our exact roadmap for decoding the examiner's expectations today. We'll start with core principles of functions, move right into our procedural solving framework, master the method mark strategy, highlight the top examiner warnings, and finally, tackle critical analysis and evaluation.
Before we get into the math, I really want you to let this quote sink in. One of the most misunderstood areas in additional mathematics. This isn't coming from a struggling student complaining on a forum. This is a direct, verified observation from a senior Cambridge examiner. The stakes here are incredibly high. Every single year, we see top-tier candidates, students who absolutely breeze through complex algebra and advanced trigonometry, suddenly hit a massive brick wall when they are asked to interpret complex function notations under strict time conditions. Why does this happen? Because functions require a massive conceptual leap. You aren't just solving a static equation anymore. You are manipulating abstract machines that process dynamic data. When Alex sees an inverse function question, Alex just tries to guess the opposite mathematical operation. When Sam sees a composite function, Sam just multiplies the two expressions together and hopes for the best. Both of them end up with 0 marks for that entire section. The difference between a passing grade and an absolute top-tier A-star distinction lies entirely in moving away from raw, panicked calculation and moving toward a highly structured, strategic approach.
Section 1, Core Principles of Functions. Let's get into the mechanics of how this actually works.
To truly understand these principles, we first have to recognize that the Cambridge syllabus demands a connected, conceptual understanding. This isn't about rote memorization, it's about knowledge that transfers to completely unfamiliar contexts. Listen closely. Every single question starts with a command word. Words like calculate, determine, show that, or evaluate. Recognizing these command words is your first split-second decision on the trading floor. For instance, if the command word is show that, the examiner doesn't just want the final answer. They literally already gave you the answer in the question. They want to see the indisputable, logical steps. And this brings us to the absolute core of the confusion for so many candidates. Let's break down the definition of a composite function, specifically f squared of x. The notation f squared of x means f of x. Let me repeat that because it's crucial. It does not mean taking the entire function and squaring it. Let's use a classic syllabus example. F of x equals 2e to the power of x. If you were asked to find f squared of x, our panicked student Sam usually writes 4e to the power of 2x. Sam just took the whole expression and squared it. That is a fatal error, and the examiner instantly stops giving marks. What the notation actually demands is that you take the entire original function, 2e to the power of x, and substitute it back into the x of the original function itself. So it becomes 2 times e to the power of bracket 2e to the power of x. It is a function operating inside itself. Understanding this causal relationship is the absolute bedrock of the entire topic. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving on, the visual and structural difference between an inverse function and a composite function is another massive trap where candidates frequently stumble in the heat of the exam. The inverse function, f inverse of x, is all about reversing the process entirely. If function f maps an input x to an output y, the inverse maps that y right back to the original x. Structurally, the strategy is simple but rigid. You let y equal the function, you physically swap the x and y variables in your equation, and then use your algebra skills to make the new y the subject of the formula. Composite functions, on the other hand, like f g of x, mean something entirely different. It means substituting the entirety of function g directly into the variable space of function f. By mastering this structural difference now, you train your brain to instantly recognize the correct analytical pathway the very moment you flip open the exam paper. No hesitation, no second guessing.
Section 2, the procedural solving framework. This is where we turn theory into actual, bankable marks.
The exact procedural framework examiners desperately want you to use is something we call the Peel framework. Now, you might have heard of Peel in your English or history classes, but we have formulated it specifically for mathematics. Peel stands for point, identifying the correct mathematical formula or principle. E stands for evidence, substituting your specific given values into that formula. The second E stands for execution, performing the algebraic manipulation with crystal clear step-by-step working out. And L stands for link, linking your final mathematical value back to the specific context of the question, complete with units or domain restrictions. Let's do a quick interactive challenge. Imagine a 30-second timer is ticking down on your screen right now. I'm going to show you a process, and I want you to spot how Peel applies. If we give Alex and Sam this precise 5-step sequence, their chaotic 0-mark answers completely transform. Step 1, deconstruct the question and highlight the command word. Step 2, extract relevant data and write down the given functions clearly on the page. Step 3, select the analytical framework. Ask yourself, is this an inverse or a composite situation? Step 4, execute with clear notation, which is where your algebraic manipulation shines. Step 5, present with correct terminology. When you follow this blueprint, you aren't just doing math. You are presenting a logical, auditable trail of evidence that the examiner can easily follow. You make it impossible for them not to give you the marks.
Section 3, the method mark strategy. Now we're talking about the real secret to exam success. This is where you actually win your points. In the Cambridge marking scheme, you need to understand that not all marks are created equal. You have B marks, which are awarded for a correct independent statement. You have A marks, which are given for absolute accuracy in your final answer. But the most important valuable currency on our trading floor is the M mark, the method mark. Method marks are awarded for demonstrating the correct procedural step, even if you made a silly arithmetic error further down the line. This means if you write down your steps clearly, you can actually salvage up to 80% of the marks for a massive 8-mark question, even with a completely flawed final answer. Let's do a 60-second rewrite attempt. If Sam's original answer was just a wrong final number, it's 0 marks. But if Sam rewrites it, showing the substitution, showing the algebraic rearrangement, suddenly the red pen marks transform into green check marks. Sam gets the M marks. This is the mathematics success blueprint in action. So let me pose this question directly to you. Why do students find interpreting complex function data so hard under pressure? Think back to your last mock exam. Was it actually the algebra that defeated you, or was it the sheer overwhelming visual layout of the question when that clock was relentlessly ticking down? The psychological reality is that under pressure, your working memory physically shrinks. If you don't have a systematized, step-by-step way to process the visual data on the exam paper, panic sets in and you resort to guessing. Cambridge assessment frameworks explicitly prioritize analytical depth and logical, structured reasoning over superficial breadth. They want to see how your brain works. Method marks reward clear working, verification, and cross-topic connections. If you were solving an equation to find where an inverse function intersects with the original function, the examiner wants to see that you realize they always intersect on the line y equals x. If you just state that, boom, method mark. If you show the substitution, boom, another method mark. It is all about the process.
Section 4. Top examiner warnings. We are about to jump into our interactive workshop, but first, I need your full attention. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get into the interactive workshop. We are looking directly at the principal examiner reports. These reports are literally the examiner's secret playbook. They tell us exactly where thousands of students threw away easy marks last year. If you want to operate at the top level, you have to learn precisely what everyone else is doing wrong so you can systematically avoid those traps. Here are the top 3 universal mistakes. First, forgetting proper format, like writing y equals in your final answer instead of the required f inverse of x equals.
Second, failing to check presentation, resulting in a messy, chaotic page where the examiner literally cannot distinguish a power from a base number. Third, providing answers that are not specific to the context given. Let's do challenge 1, the data scan. Imagine a complex graph on the screen for the function f maps x to log base 10 of x, for x is greater than 0. You have a 60-second visual countdown timer taking right now. What is the core trend you need to extract? Time's up. The core trend you must extract is the Domel restriction. Why is x strictly greater than 0? Because the logarithm of 0 is mathematically undefined, and the logarithm of a negative number does not exist in the real number system. This creates a vertical asymptote at the y-axis. Now for challenge 2, find the flaw. I'm going to show you a flawed sample paragraph from our rushing student Sam. Sam wrote, "To find the inverse, I swapped the variables and calculated the log, so the answer is -5. You have 30 seconds. Which sentence loses the marks?" It's the final statement. If the original function was restricted to x is greater than 0, an inverse output that doesn't respect the domain and range swap is entirely out of context. You must check your presentation and your final answer against the rigid parameters of the question.
Pay very close attention to this. Here is a critical examiner alert straight from Cambridge. Candidates consistently confuse key terminology. When you are writing extended mathematical responses or dealing with those heavy show-that proofs, your terminology is your absolute greatest weapon. If a question asks you to explicitly explain why a particular quadratic function does not have an inverse, you cannot just write down because the graph goes up and down. That gets you 0 marks. You must use the correct formal terminology. You must state, the function is not a one-to-one function, therefore it does not possess an inverse function. Or if you are taking the natural logarithm to bring down an exponent in the function 2e to the power of x, you need to clearly show the exact log laws you are applying. Define your mathematical actions explicitly on the page. Never, ever leave the examiner guessing what your numbers mean or how you magically jumped from one step to the next.
To combat the immense pressure of the exam room, I want to equip you with a surprising memory hack, the visual story method. Let's dive into challenge 3, speed writing. You have 30 seconds on the clock to mentally write out one perfect PL paragraph for a composite function. How do you guarantee you remember the format for composite functions like f of g of x without messing up the algebra? I want you to imagine a beautifully painted set of Russian nesting dolls. The variable x is the absolute smallest solid doll in the center. That x doll goes entirely inside the slightly larger g doll. Then that entire g doll, with the x safely tucked inside it, is placed entirely inside the largest f doll. Visualizing this physical, tangible embedding completely stops you from making Sam's fatal mistake of accidentally multiplying the two functions together. You encode the procedural format visually. So when that exam timer is relentlessly ticking down and your adrenaline is through the roof, you don't have to rely on stressed rote memory. You just recall the simple image of the nesting dolls, and the complex algebraic substitution naturally follows.
Section 5, Critical Analysis and Evaluation. This is the final piece of the puzzle. This section is exactly where we move way beyond the basic descriptive level of math and step firmly into critical evaluation. Let me be clear, this is where the A-star candidates completely separate themselves from the rest of the pack. Top students don't just operate as mindless human calculators, they act as high-level mathematical strategists. When they're faced with a brutally complex function problem, they mentally evaluate alternative approaches before they ever put their pen to the paper. Let's break down this assessment framework, because it's exactly how the examiner grades you. At the lowest level, the descriptive level, a student simply identifies the basic elements. They see f of x equals 2e to the power of x, and they recognize, okay, it's an exponential function. That's good, but it's basic. At the middle tier, the analytical level, the student uses logical steps and clear notation. They successfully apply our Peel framework. This is going to get you a very solid, respectable grade. But look at the top tier, the evaluative level. This is the gold standard. This candidate questions assumptions and actively compares mathematical approaches. If they calculate a numerical answer, they immediately evaluate it against the graphical constraints of the domain and range. They justify every single algebraic step with rigorous evidence, literally guaranteeing that every single possible method and accuracy mark is locked in and secured.
So what is the final system? We call it the complete mathematics answering system. When you are tackling the absolute hardest function notation problems on the paper, especially those brutal final questions requiring a comparison of multiple functions or finding intersections, you must follow these 3 definitive rules that guarantee top marks. Rule number 1, command word decoding. Identify exactly what the examiner is asking for. Are you looking for similarities, differences, or specific coordinate? Rule number 2, Peel framework application. Structure your working flawlessly. Use comparative connectives if asked to compare.
Support each and every algebraic step with undeniable evidence. Show the substitution, show the factorization, show the expansion. And rule number 3, the time management matrix. Draw clear conclusions that answer the specific question asked, but manage your time based on the mark value. This ties everything together. You allocate your time purely based on the mark scheme value and the cognitive demand of the question. Invest heavily in your evaluative conclusions on those 6 or 8 mark questions because that is exactly where the A-star distinction marks are hiding.
We've reached the end of today's strategy session, and I want to leave you with a final, provocative thought. Look at the screen. Will your next exam answer rely on a panicked, raw calculation, or will it be a systematic, evaluated strategy? The choice between remaining an overwhelmed Alex or a rushing Sam versus stepping up to become a top-tier mathematical strategist is entirely in your hands. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this video with a study partner who needs to hear this. Ace the Exams. Your Cambridge success starts here.